So, MathTools, again, it's going to turn everyone off with the name. What are we going to be doing with these development tools, is what I wanted to call them. If we look at what was in what we talked about earlier with when we're in this space, in game space, like we're making video games, right? We already established that most people aren't here to make board games, and you're here to make video games, which requires you to be inside of a computer, which requires you to live by the rules of the computer. And computers are mathematical things, right? So if you want to get things done, back in the day it was zeros and ones, and now we've developed languages, and even very, very high-level languages that are going to allow you to talk to the computer correctly. And I better silence this to give myself 2 hours out. So we're in this imaginary world kind of governed by that. And so if you don't understand that stuff, you're sitting in this world blind, right? So how do we understand the pieces that are in this world? How do we navigate and go find things? There are mechanics you're going to want to make in games where you need certain information to understand how it works, even certain simple mechanics. You could see simple mechanics like when we just wanted to make the ball move in Pong. How did we make the ball move in Pong? We added velocity to it. We set the velocity of it.
We added a rigid body.
My bit bucket stuff. So what did we do again?
Velocity. Added a rigid body.
We added a rigid body so that it understood velocity, and then we set velocity at a certain direction, right? And so our direction, x, y, and z, which was our vector, that tells us in this three-dimensional space, in this imaginary world, we want to go in a certain direction, right? So we have a tool and a set of tools that are going to allow us to do that. And I've harped about how important vectors are. We have this world where we're at, right? And this world where we're at, I've talked about putting things at 0, 0, 0 a lot because it makes your life easier. So when you put something at its transform, its position, that transform, when you put it at 0, 0, 0, you're putting it at the center of this imaginary universe. Wherever the Big Bang happened, if the Big Bang happened, if you're into that or believe that, where the universe was created, this would be 0, 0, 0. And when everything banged, it exploded from 0, 0, 0. So when we move 5 units to the right on our x, right, we move 5 units this way. And when we move 5 units forward, we move 5 units forward. That's in world space, right? World is always going to be 0, 0, 1 forward, 1, 0, 0, right, and 0, 1, 0 up. And we'll look at that. If you see right here, x, y, and z, if you have in the y is always up, in the right is always x, and z is always forward and backward. And when I open Unity, we'll reiterate that. So if you've lost that concept, that is like 3D World 101, is understand your coordinate system and how we're going to move things. And this is why vectors are so important in this space. And they're important in 2D too. If you hear about a 2D game in this day and age, a 2D game is still going to be done in 3D space. They just remove the X component, right? You're still going to put a game object in the world. And remember when we constrained things on a rigid body so it wouldn't move? You're still going to do those things. There's a different talk about how like Pac-Man was made back in the day when it was in real 2D pixel space. That's a different conversation. And we generally don't make games like that anymore. Well, some people probably do. But it's easier to do it this way. So first of all, you have to understand that this exists and this is the world we're in. And I'm going to be repeating myself because I know I've harped on this a lot, but I'm harping on it because it's super important. So if we're in this 3D space, we have these tools called vectors, and they are seriously the compass you have to find your way through this world. Every spatial piece of information you're going to need to know, position of something, what direction something's facing, if I want to match that direction, if I want to turn towards something, say you had a video camera or a turret, right? you ever see turrets that like find you and track you? They find you through vectors. They go like, there's a position that this guy's at, and it's like, I'm facing this way. So you come into your radius, and it's like, even being able to see him, see the person, comes through vectors. It can come through triggers too. If you're a noob, but right? But if you could make a cone of vision through vectors, and then when you wanted to get to the position of that player and you wanted to turn it, you say, look at this guy. That is done through make a vector to that guy, and then you make your forward vector, the way I'm facing, start to become that vector, and he'll turn toward that thing. And so if you wanted a turret, like most of the turret functionality, something simple, it's like turret's super simple. If you don't understand vectors, you're not going to get that done. Well, you could hack it together, I'm sure. Lots of things you can hack together. But, so, understanding that X, Y, and Z components, you understand how they're relevant to the world, that picture in the world. And that's in world space. So there's two concepts here. There's world space, and then there's local space. So world space, if I do X, Y, and Z in world space, if I say, I'm always so say this is the world. So if you're looking at Unity and you know that little thing up at the top that shows you where Z is and where X is and where Y is, this thing. Let's see if we can't find it. I should have Unity open. Did I close Unity? I closed Unity. So I'm going to make a brand new project for this because it seems everyone's scared of making a new project. And I'm going to call this, I'm going to put it in IND projects. This is fine. And I'm going to call it vector stuff. I'll make that project. So, understanding in world space, we talked about X, Y, and Z, and what does it mean in those directions. Remember, there's two types of X, Y, and Z, and I'll discuss those in a second, but we have to understand world space. Do you see this thing up here? This tells me the world space of what the actual world is doing. Like, if I click this X right here, I'm looking down the X. If I click this Z, I'm looking down the X, Z, it kind of in the wrong way. But that means in the world, Z is always going to be in that direction. Now, Z is always in that direction, and I turn this way, I still have my local Z, right? I still have my own forward. And I'll show you that with this. If I put a game object in here, and I'm just going to make a cube, okay, do you see how this cube, when it's created, it is created on the same axis as the world? Its blue arrow right here is the same as this blue arrow, whatever way that's facing. If I were to rotate this and put this back to not global, do you see how this is global and local right here? Can you guys see that up there? Okay. Local means this is to my local space, and global means this is to the global space, meaning that the world has its own X, Y, and Z it adheres to, but I have my own because I can rotate and do whatever I want. You can't really rotate the world. You can rotate things in the world, but the world is always going to have its local space, and that is going to be, we talked about vectors and how vectors represent positions and directions. So I'll get to that in a second. But these things have their own space. And so if we look at, let's get back down to the lecture, that the vectors can represent a positional space, but they can also represent a direction. All right? And to showcase that, I'm going to show you this. I know this, you're like blah, 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 vectors. Super important. I'm going to reset the transform of this. I don't know where it went. I've lost it. There it is. Okay, so do you see that there's an X, Y, and Z for the position? All right, you see how it's at 0, 0, 0? And if I move this, you will see that those positions move, right? That is a point in space that it's saying is there. But also, when I talked about directional components, right? A vector itself is made up of two components. And the two components are direction and magnitude. And this is important because we use direction a lot. We use magnitude a lot too, but if I want to find out how far something is away from me, and we do this a lot. Have you ever had like a game where you played and you were like, go to the objective, and it's like the objective is 34 meters this way. Did you ever get that information? Mm-hmm. Or even if you wanted to do something like we use triggers a lot, but sometimes it's not great to use triggers. Sometimes you want to know, am I close enough to this to do something? Right? So say if you had a door and you said, am I close enough to this door to do something? Am I close enough to this object? We need the concept of distance, right? So there's magnitude is the distance or the length of a vector. Direction is just the way it's pointing. If I said, which direction is Wendy's? Which would you show me?
Yeah, always that way.
It's totally that way. You guys have terrible space. Like,
well, we're used to being in the auditorium.
So, all right, I've been here a long time. So yes, Wendy's is like that way. But you're not telling me how far Wendy's is, right? You're just telling me a direction. So that direction is super important in games. Knowing directional information, exceptionally important. The next component is how far. If then I ask you, well, how far is it away? That would be the magnitude portion of that vector. What direction is it? How far away is it? How big is that vector? You got to stop that. Okay, so
when you mean how far away is that how far away is it like globally, or is it like say you have something in the way that then increases distance, or is it still determining?
No, globally. How far? Don't think about vectors just like that. I'm just giving you an example of what magnitude is. When someone tells you what are the two parts of a vector, you're going to see direction and magnitude. Which way am I pointing? Which way am I? How far away is it? How big is the vector? And you're going to see, and you're like, well, vectors are x, y, z, right? I understand, like I can grasp that a vector is x, y, z, and when I see this position in space, that makes sense to me. It's 5 units this way on the x, 1 unit in the y, and 5 units in the z, right? And I can put that position in the world, and that can make some sense to me. Is that technically that is a vector with direction and magnitude from the origin? But we don't have to get into there confused. Just know it can represent a point, but it also can represent a direction. So remember, I'm going to get into normals, and we talked about normals, but if I said what direction is up represented as a vector?
That's a y.
So we solved the first problem. It's on the y. Positive, right? So we know that. So if you can understand that concept, the concept that if I asked you what direction is up, if you said 0 on the x, right? I don't care about any x. I don't care about any z. 0, 1, 0. So representing a up vector is 0, 1, 0. What is representing a right vector?
1, 0, 0.
1, 0, 0. And a left vector?
0, 0, 1, 0, 0.
Right. Z would be 0, 0, 1, and backward z would be 0, 0, negative 1. Now that is in world space. So if you're thinking in world space, that means in the world, point me straight up in the world. I don't care where you are. Point me straight up, right? And forward would be forward in the world, and right would be right. And so why does this matter to us? I'll show you somehow. Because it's super cool. We're going to talk about these things here, vectors, the parts, and how to create a directed vector and stuff like that. So we have the transform, and I already mentioned that we understand the concept of position, but we also have to understand that this transform holds that information that shows us our direction, right? It shows me what my right is, and what my forward is, and what my up is. And my up is usually still up unless you're doing some crazy mechanic where you flip the character upside down and he walks on the ceiling, or you need to have something where you're checking the up vector. And there are those things, right? So if a person walks, if a car drives up a hill, does the car tilt? So its up is not going to be straight up anymore. Its local up, the world's up, still going to be straight up, but its local up has changed because it is now driving up that hill. Characters you generally don't do that with. You usually keep them upright, so you can assume that sometimes, depending on your mechanics, you can assume that their Y is straight up. But when we use generic behavior, a lot of people like generic behavior. You can get some of this information out of generic behavior, but it's easier for me to show you in code some of this information, just because accessing some of those things is a bit difficult. But understanding that I have my own vectors, and again, I'm calling these things the compass of how I figure out what direction I want to move and how I want to move my character. Remember when I showed you, I think last class, I showed you that little cylinder that I moved with the 3D camera? Very simple code, but it's going to show, I'm going to do that again, and I'm going to show you guys how to do that, but it's going to show these axes that I'm moving on and my local directions. So even just getting character movement to work directly. If you don't understand vectors, you're going to have a hard time getting a character moved in a meaningful, a way that you like. Okay, so I talked about directional vectors. I talked about position, or I talked about direction and magnitude, right? Does everyone understand that concept pretty well? Just there's a direction and a magnitude of the way that we're going. And so when I talk about a directional vector, we need to say, how do we create a directional vector if we need to? And I'm not even going to get into that yet. I'll get into all the fun things in a second when I open Unity. So you're going to hear the word normal, and we discussed normal last class. Remember when I said surface normal? What is the surface normal of the floor? Up, right? And so the surface normal of the floor is up because this is the direction the surface is pointing. If the force pushed against me, what would that be? It is up. The normal of the ceiling is down, left, right, front, back, right? It's the opposite of the surface. So they call those normals. But you're also going to hear another term called normalize. And the concept of normalizing a vector, and it doesn't need to explode your head, like it's not, but it is just getting the direction component out of a vector. It's saying, I don't care how long the vector is anymore. All I want to know is what direction am I pointing. So what it does is it takes all the length out of it and makes it length of 1. That's important because when we're talking about your forward direction as a player or the forward direction in the world, we don't care about, those are normalized vectors. And so normalization on vectors is just that. Length of 1, give me the direction component. Okay, so creating a directional vector. Let's get out of the nerdy math talk that people don't seem to care about, and let's do something in the game with these, so you guys can see something functional by using these in the game. Let me see what the rest of the stuff. Dot product using the tools. Okay. We'll create a directional vector in game and use it for some reason. All right. And so this was an empty project that I made, and I'm just going to make a floor real quick that I can walk on. Doesn't need to be fancy. And I could make that super cool guy cylinder again with sunglasses, but I'm not going to in the interest of time.
Well, you did save him.
I saved him in another project as a prefab. That is correct. Oh man, I could do it. I could do it real easy. And so I'm going to put this at 0, 0, 0. I'm going to bring him up a little. All right, let's make a material for him. That's fine. That's fine. Okay, I've got a guy. And actually, I want to see his direction right now, so I am going to put something on him. And since that's an easy way to do it, fine. We'll make cool guy sunglasses on this guy. And Unity already did, like, this is like Unity's kind of thing they did for a character. Create material. Black. And we want these to go on the front of the character. So let's look at which way. Which way is the character facing right now? This is also important. So,
isn't it towards the red line on the X direction?
well, so okay. So this is important. If you don't know this is extremely important. Blue line. If I want to move right and left, that is what component?
Red.
Right and left, right? Up and down is Y. Forward and backward is. This video is going to be the worst.
Yeah, just drag it all the way down. It just kind of disappears slightly.
Fine. So it's important to know that Z is my forward, right? That's forward and backward. Red, right and left. Green, or X, Y, up and down. Z is my forward. So I want to put these sunglasses on his forward. So just knowing that information is really important to even creating Sunglass Man.
I was being stupid. I was thinking 2D space.
Right, and so I put this guy at, let's put him back at 0, 0, 0, so we can parent this correctly. Those sunglasses are a little big. All right, so these, if I parent them now, good. There we go. Super awesome Sunglass Man. Yep. And actually, his sunglasses are a little Terminator glasses. Okay, so that's parented now. And if we want to move this character, I want to see what direction he's facing. So I can get some directional value based on which way he's facing now. And so if I want to, what I want to start doing is I want to show you using vectors to move something, right, in this space. It's going to help you understand what it means to move around in space. And you're going to want to do this. And you've done this with generic behavior, and you might have done this in code, and you said, I want to apply a velocity in a direction. What does that mean? Well, it was easy for us in generic behavior with the ball because we were using world coordinates, right? We were saying, ball, I want you to start with 1 on the y, 1 on the x, and 0 in the z, and that thing went diagonal upright, right? And that made sense because we're in the world on that. And we can use world coordinates to do that. But if we don't want to use coordinates, we want to use our local coordinates and say, I don't care what direction I'm facing, move me forward. And when you have 3D games or 3D characters, that's generally how you like to move, right? You don't say, move me only on the x and y of the world, or the x and z of the world. You're like, rotate me in a way, and then please move me along my forward. Does that make sense? Yeah. So we need to know what forwards are and what our right is, and on a local term, and these are all represented by vectors. So If I want to move this guy, we have components here. If I want to move him with physics, what do I need to add? Rigid body. Got my rigid body. Okay, I want to use gravity on this guy. So this guy should fall. Whoa. What did I do? I put the rigid body on the floor. Okay. Let's try that. So the floor was actually falling, and it made the makes sense now. All right. I don't want a rigid body on the floor. Floor has no reason to have a rigid body. It was an oversight. Thank you for catching it. Okay. Oh, he fell over. Poor guy. That poor guy. So we need to constrain him so he doesn't fall over. I don't want him to rotate on his X, and I don't want him to rotate on his Z. Do I? No, I only want him to rotate on his Y, straight down, right? So when you're looking at rotations, yaw, pitch, and roll in rotation space is, think about rotating on the axes that there are. Y is always what?
Up and down.
So if I were to rotate around this, I would do what?
Up or down.
You don't rotate, you just go like this way.
Yes, I would. If I'm gonna rotate around this axis, and I'm gonna look really stupid doing this, but I would rotate around this axis, right?
Now rotate on your X.
X-axis is pitch. So like a cannon. If you wanted to do a cannon, right? So think, the line that runs through you on my X, my right, is the one I'm going to rotate around.
Right.
So I'm going to rotate around this portion here. I'm going to do this, right? Think of it with my hips. I would pitch up and down. If I was going to rotate around this, what would I do?
Do a somersault.
Not a somersault. A somersault would still be the X. I'd be going this way.
Cartwheel, that one.
Cartwheel, yes. Or like, think about a plane flying, right? So this is really good with planes. It's called yaw, pitch, and roll, right? And so think about a plane flying. Cars, well, some cars do, but if a plane tilts this way on its forward, it's rolling, right? It's actually rotating on its Z. Do a barrel roll. That's a barrel roll. Yeah, barrel roll is rotating on the Z, right? If you wanted to spin around, think of the axis that you're using out of the X, Y, and Z axis. So even the axes that we're defining, everything is defined by vectors in this space. So you said, I want to do a barrel roll. Barrel roll is the mechanic I want in my game. And you're like, make it happen. And they're like, I don't even know what to do. Well, now you do. If you wanted to make the mechanic do a barrel roll, you could probably rotate your guy around your Z in a bit, and then translate him to a direction where you're going, and make him turn off his collider for a certain amount of time. He would become invulnerable. Things would pass through him. He would do a little spin, and you could do that. Now, as a developer, or as a designer, you could say, I don't do a barrel roll, and it's not just a funny thing to say, right? You could actually make that happen. You could spin the guy, and then turn off his collider, and then turn it back on after a little bit of time, and you have that mechanic down, right? Not hard. You just need to know the pieces for it. So I know I want to move this guy with a rigid body. I'm actually going to add a script to this guy. I got to make a new script. So I'm just used to organizing my stuff here. Scripts. Create C# script. This is going to be called cool guy. Cool cylinder. Right? Okay, so we started with an empty project. We started with nothing in this project, and we're going to move this guy in third person. And one of the things I'm going to do first, so we have the camera, I'm not going to write a special camera code for this. I might write it, but for right now, just so we can see this happening, I'm just going to parent the main camera to this guy. And when I do so, I'm going to bring it up a little bit, and I'm going to rotate it down a little bit. And I'm rotating it down, so if I want to do this, what axes would I rotate it on? X. X is represented by red, and Unity goes like, got you. I know you want to do that. There's red, so I'm going to try to grab this red thing here, and I'm going to tilt it down a little bit, and move it up a little bit, And when I play the game, I got the camera. It's going to be locked to that guy. All right. So I made this cool guy cylinder script. And on my capsule, well, I'm not even going to apply it yet. Okay, blank script. It's not completely blank. Unity gives you some things. Super scary. If you remember in some of the other things, I want to move this character. What do I use to move it? This, because I just added a component. I use the rigid body velocity, which is contained by the rigid body, right? So I need access to the rigid body in this script. So does everyone remember that if I attach the script to a game object, I have access to eventually, but I have to get it off of the game object. So I automatically, once I get on this thing, I know about my game object. I know about the object's game object thing. All right? So if I want to do that, I need to, off of the game object, I need to get this rigid body component so that I can start manipulating, right? I want to start manipulating its direction, I want to start manipulating its velocity, and I want to start moving this thing, all right? So let's do a private, because I don't want to do this, we're gonna do this. RB for rigid body. So actually, I need the type. This is the type, rigid body, and the name is RB. All right? And RB equals, I can get access to the game object, and rigid body is what? What are these things? If I click on this capsule, what are all of these things? Okay, and what do I want to do?
Get component.
I want to get that component. Get component. And then weird syntax that you have to use. What is the component I'm looking for? Well, rigid body is the component I'm looking for. So I'm not getting the velocity yet. All I'm doing is assigning that rigid body to this variable I made so that I don't have to type this all the time. I could type this all the time to get it, but I'm just making a very simple thing that I can use all the time to do this, right? And so if I just did rb.velocity, I can't do that. It's a good idea. Looks ugly, but maybe it'll help you guys. If I did rb velocity equals new vector 3, parts of a vector 3 are, what are the three components of vector 3? All right, I want to move this guy on the right. What do I do? 1, 0, 0. What if I want to move? So 1, 0, 0 is a good point. That is a normal, that's just going to say, at a unit of 1, which is a normalized vector, move him along that. And I can do that. He'll slowly move to the right. If I wanted to move him faster, I could make the number bigger, or I could scale this vector. We'll get into that later, right? But if I wanted to just do 2, 0, 0, or 20, that's going to be bad. And I save this. All right, I have, if I attach this script, add component, under scripts, cool cylinder, he's slowly moving to the right. See that?
He's also slowly falling.
Was he falling slowly too?
He just went insane. I don't know why he went insane. Yeah, I could do that too. Clamp that, freeze that rotation. Slowly falling. Why is he slowly falling? Well, gravity affects the velocity of the character. It actually it adds an acceleration to the character, which is down. I'm saying I don't care what velocity is. Every frame, what happens in update?
Every frame.
Update every frame, so 60 times per second if you're running at that speed. I'm saying screw gravity, set it to 0, right? So do you see why that made him not fall correctly? So I know I want to move him on the right, but I want to keep the rigid bodies rb.velocity.y for the y component. Let me put some spaces in here so you can see things. Right? So I say I don't want to override his velocity in the y. Let gravity take care of that, please. Right? So now I'm just saying, all right, gravity take care of it. And he'll fall as gravity wants, but he'll still start moving to the right. All right? Is he still spinning?
No, my guy's spinning.
Oh, clamp the Y. Freeze rotation on the Y for your rigid body. All right, so here's where the kind of fun parts come in. All right, I don't want to move on 2, right? I want to move on the direction I'm facing. Yes, I want to be able to use input to actually move this character around and not just say move to the right always. You may want to do that at some point in time. So to do that, I'm going to say, all right, input dot axes get axis, and this is the x component. So the axes for input are you can make new axes if you want, and all an axis is -1 to 1, and your input usually runs on an axis of -1 to 1. Right, so you don't have to really completely worry about that right now. But on the x, is the x vertical or horizontal? Okay. And I guess I could show you this in Unity for clarity's sake. If I go up to project settings and go to input, and I look at axes, do you see how these are the axes I can actually use? Unity already understands these. So it knows what it's assigned to. So horizontal is assigned to A and D, left and right. So you can make these axes on your own if you want. But I want horizontal. Okay, and so this is going to give me a value from -1 to 1. All right? What do I want for the z? What axis would I use for the z? Well, they call it vertical. Okay, so now, instead of just moving to the left and right, I'm saying my new vector of movement, gravity, just be gravity. Get the rigid body velocity. I should be able to press A and D and move super slowly to the right and left. All right? Super slow.
You're also rotating, it looks like.
I'm not. I will in a second. But that was too slow, right? So let's speed that up a bit so that we can control how fast we move. I'm going to make a public float, and I'm going to call it speed. Public means what? I'm going to set it to 1 initially.
Everyone can access that.
Everyone, including every other script if I wanted to, if I was using this in another script, including the editor. See how speed popped up right here? So I made that. If I made this 5, it's still not going to do anything because I didn't multiply these values by it. So again, these are -1 to 1. It can be any range between -1 to 1 on the axes. When I'm not pressing anything, it's 0. When I'm pressing D, it'll go all the way to 1 for that axis. So if I multiply this by speed, I still don't care about gravity. Gravity, you do you. You just put spaces around you. You are the y component. And if I multiply this by speed, so if I was making comments on this, I could say, this is my x, this is my y, and this is my z velocity, right? And so all this stuff is that. So now I should move faster on those axes. Not much faster. So still doesn't like me to move that much faster. Let's see what's wrong with that. Times speed. Speed equals 1. Set it there. Overwrite it. Did I save? I did not save. Now I'm moving faster. You see that? But I'm always moving in the world z and the world x. That's good because I'm facing that direction right now, right? So I'm always moving on the forward in the world and right in the world, no matter what I press. So why don't we allow me to rotate this character real quick? And so to rotate the character, now we're going to get into interesting things about the transform. So the transform, since we're in this vector space, this is the information the transform holds, right? Up until now, we've been basically just talking about positional stuff. Transform is going to hold your position, right? But it also holds rotation and scale. So we want to manipulate, we want to rotate this. And Unity is really cool about that, because it's like, I know people want to do that. So I can just do transform dot rotate. Dot rotate. All right. And what does, remember when we talked about functions and creating functions? That's probably, yeah, you guys can't read that. It's okay. It wants a vector 3. It takes in a vector 3. And so I want to move, I want to rotate this way. What axis is that on? The y, right? So if this wants a vector 3, I can pass in a new vector 3, and I want some number on the y. But I want my mouse to use this, all right? So since I want my mouse to use this, I'm going to check for input again. Input dot get axis. And this also has, if we go back and look, I mean, this is stuff you'll figure out eventually. If we go back and look at the axes, edit, project settings, input, there happens to be one for mouse X also. And it's on the X axis of the mouse. So the mouse sits on a mouse pad this way, right? Which ways can you move the mouse? Does the mouse care if you lift it off the table?
No.
It only has 2 directions. And so if I flip that down on here, its directions are like 2D space. Now you would say that that's Z, but it's not on that for the mouse. The mouse has X and Y, 2 dimensions. It can move up and it can move left and right. Left and right is going to be the X, right? So I'm going to say I want the mouse X, and I have to spell it correctly. But I've done something wrong here. I don't want it on the X, which is the first part of that, right? And I don't want it on the Z, which is the third part. I want it on the Y. So on this again, this is going to be the X component of this, the Y component, and the Z component. Because I'm making a vector, right? They're always going to have X, Y, Z, and I'm like, what axes do I want to spin on? And you're like, Y. So I'm putting this in the Y portion of the vector. Does that make sense to anyone who's still awake? That doesn't make sense? All right, I can explain it again. If you get lost here, you're going to have trouble doing this. So if you don't understand that the vector is 3 parts, and when I want to do something around rotation, which you will want to do at some point in time, then you're dealing with the X, Y, and Z on what axes you want to go on.
You need to get 2 poles. Probably be easier.
I need to get 2 what?
2 poles.
2 poles?
Like Y pole and X pole, and then you can
Oh,
Like, next.
like, okay. I see what you're saying. So if I'm doing this, I should be able to rotate my character by moving the mouse. All right? So if I do rotate the character, do you see how I rotate, but I'm still going to be, I'm holding down W, right? And as I'm holding down W, see how I'm still moving in that direction? I'm not going along my forward. What forward am I going along?
Global.
The global forward. Because I'm only saying this is the global, like all I'm saying in the script that I just did is there are components to this vector, and this is the movement code, and this is the rotation code. But I said this returns a value from 0 or -1 to 1, and I'm like, just make that bigger, right? So that is always going to be just that, all right? We don't want that. So we want to be able to do something different here. And what we want to do for moving on this is we need to get, if we look at I don't know why this is doing this. Game object dot transform. All right. So when I said that the game object, you always have access to the game object, but you can get its transform without having to do get component because they're buddies and they always hang out together. Game object and transform always hanging out together. So we don't need to use get component on that. But if you look at the transform here, what does it show me here? Position, rotation, and scale, correct? That's not the only things. Once you get into the transform, you can see there's a lot of other things that it has, all right? So it has all of these. I could set parent. I can do a ton of things on this, right? So if I wanted, it also tells you what direction it's facing, all right? So when I say I press W, what direction do I want to move? Forward. Let's type that. Forward. It's there. All right, so what that represents is a directional vector of my forward.
Positive 1 on Z.
But it's not always going to be that. And I'm going to show you when I start rotating this. It's not always going to be that when I'm doing that. It's positive 1 on my local, but in the world it becomes something else. And so I do want my forward. I don't want the world forward anymore. I want my forward. So I'm going to, and these are vectors, right? I'm going to make a vector 3, I guess I can call it forward. And I'm going to make a vector 3 right, and do the same thing. Transform dot right. And I don't care about up, because what takes care of up for me? Moving in the up and down. Gravity, or unless I jump, adding some type of force. Okay, so now what I want to do is I need to use these to actually move my character. I need to use this vector to move my character. So I'm not, I can do right in a second, but I'm not going to show you that. The velocity I want is not this anymore. I want to move on my forward. So my forward, I'm just going to type in forward times speed. And so now, when I do this, do you see how I'm moving on my forward? Instead of just in the local, I can actually move along whatever my forward vector is. So if my transform rotates, it's going to say, I don't care how you rotated this thing. Move me along your forward vector, the direction you are facing. not the world's direction.
Still going.
Yeah, but there's no gravity on these.
No, I never told it to stop. Actually, hold on. I should have told it, because he's still going because I didn't do something here. And what I didn't do was I didn't check for any keys. I didn't check for any input. If I get rid of this whole line, do you see what this is doing here? I have to get rid of all this too. This is saying don't even check for input. Just move me forward. I didn't notice it because right when I started pressing W. And I'm like, this is working. Totally wasn't working because if I save this, all that's going to happen, it's not looking for any input. It is just, forget this. That thing's just going to go with no input, right? Where I got the input from was W and S, so I need to check for that also. So this input dot get axis, and this was vertical, and I want to multiply that by that. So this forward vector is my forward vector, and it's going to say multiply it by the axis, which is -1 or 1. So that just says become, or if I'm not hitting anything, that becomes 0. What's anything multiplied by 0? Right. So if I'm not hitting any buttons, my velocity should be what?
0.
Because the whole thing is multiplied by 0. Even if after it's multiplied by speed, because it goes, if this is -1 or 1 or 0, 0 multiplied by whatever this vector is, times this, it's always going to be 0. So now I should be able to control that. Okay, so that gets using vectors gets simple movement, but we can only move left, or we can only move forward, can't even move backward right now. Actually, I can move backward because I did get axis. So I can move backward. I'm still going to have the problem with gravity, so I could add gravity to this. RB dot velocity, adding gravity to this is the y component. Yes. Plus it doesn't really matter that I'm adding this other stuff to it. Plus this is going to be horizontal. This is going to be right. Is that correct? And then this isn't going to, gravity's not going to work on this right now because I have to put that back in, but I don't need it to work right now. So now I can hold A and D and strafe, and I always strafe along my right vector. So this is like the worst third-person camera controller in the world. Like baby's first third-person controller. I can't rotate the camera around. I can basically just move. The camera's parented to my guy, and I can move forward, left and right, or in a combination of both of those. But all done with vectors. Everything I had to do to get that done, which is simple movement, right? If you look at the steps I did for simple third-person movement of changing velocity, is I made two vectors and got the forward vector and the right vector. This velocity is a vector. I set this velocity to scaled versions of these forward and right vectors based on input. Then I rotated, which takes in a vector, along an axis that I want based on the input that I'm getting. So who's lost on that? It's okay if you are. Kind of get it? Yeah. Given that, do you see the importance of vectors when making this stuff? Like nothing happens there without a very good understanding of vectors. Yes?
Mine won't take my input. Mine takes my mouse input, but don't move.
Okay, I'll answer specific questions during lab on this. So, if this is boring, but it could be boring, and it might be difficult to wrap your head around. But do you want to get functionality like this when you make video games?
Yes.
Yeah. Right? This is how you do it. And so, if you're like, vectors, they're a thing that someone else will figure out. That is like you're going to need to learn how to master using these things and understand every time it asks for X and Y and Z and the difference between local and global and moving your character, or I'm going to show you some other things real quick on information about that. Super important. It is 100% how you move, how you navigate, how you find things, all the information you need about navigation in space in your 3D world is wrapped up into these things. So if you're confused in any way and you need help with these, come ask me for help and I will show you I'll try to give you some more one-on-one. If you're like, this is not for me, you are going to have a hard time in the world that you are entering. If you're like, I don't get those, I don't like them, I don't want to be their friends, I'm going to do this without those. It might be possible. You're going to have a real rough time. So, I don't like green. That's okay. As long as you like vectors, if you're making video games, you're going to have to understand those concepts. And realistically, if you're using Unity and you're pulling a thing around and you're rotating it, you already conceptually understand these concepts. You understand that this thing has a forward. When you rotate it, you understand that its forward has shifted in a different direction. If you want to move it, you visually understand that. We just need to harness the power to manipulate that the way we want it to. All right? And there's other cool things that we can do with this. So if I put another object in the world, and if we go back to the lecture where this started, creating directional vectors and why it matters. I'm going to talk about creating these vectors and not using them I did vector usage for movement. All right? Rotating and translating my character and moving him around and rotating. All done with vectors. Vectors and input. There was nothing else done with that. Creating a directional vector, and then there's this magic thing called the dot product. And it is going to be how you figure out a lot of things in space. So we are in space. If I wanted to know, am I in front of this thing or am I behind this thing? You could use a dot product for that. If I wanted to know if you were to the right or left of me, remember we were talking about a long time ago if someone played an animation and they were coming from the right? This is like someone brought this up and said, what would happen if someone came from the right and I wanted to play I got hit from the right animation, right? So if you wanted a thing where it's like, dude's over here and he hits this way, I don't want to play this animation every single time, which some games do, right? Older games. But new games go like, I need to know if he's swinging at me from the right so that I can appropriately react. Finding out if he's on my right or my left, dot product. Finding out if I wanted to go backstab, if I wanted to stealth behind someone, dot product. If I wanted to backstab someone, dot product. Right? You might not want to make games like this, but spatially knowing information about yourself and where other things are around you is important in a lot of mechanics that you're going to want to use.
So games like Splinter Cell and Hitman use the dot product.
Guarantee every game you've ever played uses the dot product. No, I can't guarantee. I cannot guarantee that. I could say 90% of the games that you've ever played have probably used the dot product.
What would be an example of a game that doesn't use that product?
I can't even think. I mean, well, Pong didn't use the dot product, right? Pong did use the dot product. You just didn't know it.
What?
So you use vector reflect, right? I think so you're calling functions in Pong like vector reflect, right? Did you write vector reflect? You did not write vector reflect. We called it, even if you were using generic behavior. We called it in code. If you used it in code, I show you how to do that with vector reflect. But if you used it in generic behavior calls vector reflect, which I'm pretty sure uses dot product.
So you did.
So you did. So something like what I said is I've done no math. The only math, I haven't done any math yet, right? When I said there's going to be no real math in this discussion, and the lecture was called MathTools, have we added anything together yet?
No.
We did. I added one vector. We haven't subtracted anything. We haven't done long division. We are trying to harness some concepts that are going to be useful for you. Like the excitement, and I understand that we can get lost in the kind of the X's and the Y's and the Z's and like considering spatial stuff, and you can get bored with that. But every time I ask, do you want to get this done in the game? People are like, yeah, I want to know how to do that. And so getting excited about knowing how to do this, and you get this through practice. Like you're going to practice this, and when you finally work at it and put it in, it's going to feel foreign and weird for a bit, and you're finally going to get it and go like, I can now master these things. I can master 3D space, or even 2D space because you're still going to move in that stuff. And I have the ability to do that, which makes you then the ability to say, I want to test out this mechanic and make this little game and say, I want to move differently. Because in my game, because I'm a super awesome designer, my game flips. My guy flips upside down and runs on the walls, or runs on the ceiling, right? Which has been done 1,000 times. So, but you may want to do that. And knowing how to do that is important. So, what's up? What do you say?
No, you go.
Okay. What time is it?
2:15.
It's that time? I cannot believe you're not super excited about this. This is like the most.
You can't tell this.
This is like the most exciting, useful thing to learn about for game development.
Feel like we needed awesome tools.
I hear a question.
It is cool.
Keep it down. So I'm just going to show you this really quickly, and then I'll let you guys go after I show you this stuff. So I can move my character, and this was started from scratch. Using vectors, I can move my character. I'm going to put something else in the world. I'm just going to create an empty, not parented to that. Yeah, cube's fine. All right, and this thing, I don't need it, just it can represent a cube, and I'll put a black material on it so we can see it. All right, so I have this cube in the world, and I'm going to show you how to make a vector to that cube and why it's important also. So if I make a new vector, and I can do that anywhere here, I'll make a new vector up here.
Does it need to have a rigid body?
It does not. So when you ask that question, and that question is asked a lot, why would something need a rigid body?
Only if we're going to use physics.
Use physics on it. I don't care if this thing moves. I don't care if this thing bounces. I don't care if I'm not going to control this thing. I do not need a rigid body on this, right? So it is just going to be something I'm going to test distance and orientation based on. Think of this as it could be, and I'm going to make evil cube guy.
Oh no.
Actually, hold on. This is.
You're gonna have red sometimes.
I'm not going to make evil cube guy. So I'm stealing this. So it's not super mine. This has been done before. No. Yes, I'm going to do that. But All right, and I'm going to make, you said reverse the color scheme?
Yeah.
All right. So in materials, we're going to do
Hit 'em already.
right. All right. So this is not cool guy. Put him in prefabs. And this is fine.
behind you.
All right. So we put him there. I'm going to put this guy here. Problem is this guy's going to move with me, right? I don't want him to move.
It's like Watson.
So I'm going to take this off of him. Take the script off of him. Apply it to that. So he doesn't move now. I can move around him. All right. So if we wanted to know certain things about this, say we were making a stealth game, right? There's a couple things that we could do with this. If I wanted to know the distance to that guy, right? Let's make a vector 3. Distance. That's fine. We're going to make a game object so we have access to that guy. Public game object. Bad guy is fine. And so what I'm going to do is distance. I'm going to make this equal. I'm going to make a vector. Remember, vectors have two parts. What? Where are they? When I said we're going to Wendy's, what are the two parts of a vector? Direction and magnitude, right? So I'm going to make a vector pointing toward this guy. All right? And so this is important because I want to know, because not only do I know what direction he's in, I also want to know how far away he is. Because if I'm really far away, should he be able to see me?
No.
Okay? So I'm going to make a vector pointing to him. All right? And the way I do that, the way you make a vector pointing to something, anything in the world, is it is that thing minus your position. Right? Magic. This is a little bit of math. Sorry. So I have bad guy, and the bad guy is a game object. Game object's best buddy is what? Does it always have to tell it where it is in the world? Transform. And I care about its position. Minus my. Okay, I have a vector to that guy now. And I called it distance. It shouldn't be called distance. That's a bad name that will confuse you. It is called vec to bad guy. Bad guy, name it like that, right? That is a vector to the bad guy. All right? And if I come in here, and let's just make something real quick for you guys to see. I'll make a UI, make a canvas. You don't want it parented there. And make a text object. It's fine where it is. And in my character, I make a text object. This you don't like. This isn't super important. If I want to know, so this is the vector, direction and magnitude, right? I want to know how far away this guy. That is what portion of that?
Magnitude.
It's the magnitude, right? So the magnitude. I want to know the magnitude. So I can get that, and the magnitude is held by a float, right? It is a float value is the magnitude. It can be less. It can be bigger than a whole number. but the direction's always a vector. So if I want to in text, my text dot text equals, if I did vector bad guy dot magnitude. All right, do you see this is, it returns a float value, returns the length of this vector. And I need to do toString because text is a string. And how I'm drawing this doesn't necessarily pertain to what the importance of it is. I did. I forgot to assign it to my guy. So cool guy needs a bad guy. He needs two things. He needs my text filled in, and he also needs not cool guy filled in as bad guy right here. All right. And do you see how that number is getting bigger and smaller? And when I get real close to him, I could push him because he has a rigid body. But now I'm extremely close to this guy. And now I'm farther away. This information for games and for doing things is important. And to show you how that was done again,
Can you show us how to do the UI part of it?
I'll show you later on how to do this. This lecture is not about UI right now, so I could show you how to do that later. That was just getting the bad guy by just making a public variable and dragging him in, making a vector, a directional vector. I just made a vector that said this is a vector to that bad guy. Then getting the magnitude component of it. Now I have a lot more power. Now I can check distances. So in your game, could you say, do I know how to move a character with vectors? Yes. Do I know how to check to see how far away from something I am? Yes. Also, by making that directional vector, do I know where something is? Well, if you make a directional vector to it, you know where it is. You know what direction it's in, and you know how far away it is. That's pretty much map directions to, you didn't have streets and stuff. As the crow flies, you know where any object, you can find where any object is in the world. That's a lot of power in video games. Movement and manipulating you in 3D space, and then finding other objects in 3D space. And then the last thing I want to show you guys on that is I want to change the color of my character based on if I am in front of him or behind him. All right? So this would be stealth, right? Very simple stealth. But in front of him, behind him, the concept of that is only possible by what concept? Knowing which direction this thing is facing, right? Because if it was just a sphere, there'd be no concept of that. I have to know what direction that's facing. How do I know what direction something's facing?
The blue line.
The blue line, and that is what?
Z.
The Z, and we did transform dot. What direction am I moving? Forward. The transform knows whatever it knows it's forward right now. All right. So since it knows that, we can do some magic here. And the magic we're going to do is I'm going to get a float because the dot product returns a float. And I'm not going to do the math for the dot product. There's math that is involved with this. You don't need to know the math. You don't need to know how to build an engine to drive a car. You just need to know what it does and how to use the tool, right? So half space. Equals, and this is going to be, this dot product takes in two vectors, all right? We're going to learn about just the simplest, highest level of the dot product. It takes in two vectors and compares them for information, all right? If I show you, this is going to be another math thing that you're probably going to hate.
That's vector dot dot.
Vector dot dot, yeah. You guys are gonna die. I hate this.
It's been a long time since
All right. So listen. There's only four things. There's only four things on this. This is called the unit circle. Believe me, if you are going to get a job somewhere, they're going to ask you, do you understand these concepts? These are not even programming concepts. These are just 3D space and math concepts that allow us to figure things out. All right? So there's only four things you really need to care about for right now. Later on, when you get a little more advanced, you can care about more things. Do you see the axes on those? What are the two axes that have? Great, X and Y. We understand those concepts, right? Yes. So we see 0, 1, 0, negative 1, and 1, 0, and negative 1, 0. Do you see how this component right here, since this is, imagine this is a 2D vector. A 3D vector has what components? X, Y, and Z. Okay, a 2D vector only has X and Y. Great, so we're dealing with 2D vectors here. On the Y, do you see that when this, coming up this way, this is 0, 1, and then it starts to go into this weird stuff when it's not here? But then, so this is 100% on the forward Y, all right? Then it's like fractions on that going towards the X until it's 100% on the X. So to understand two vectors, why this takes two vectors in, is it is going to compare these two vectors to give you one of these values. And so if I'm facing in the same direction, if I draw something for you here, and I have paint, all right, so this is what we're going to do with, if I have, this guy is my bad guy, and this is me, top down, right? All right, so my bad guys, if I want to know if I'm facing the same direction as this bad guy, right? Because can I backstab someone? I mean, I guess I could, if he was behind me, I guess I could backstab him this way. But for a game, you would probably want to know if you were facing him and behind him, right? So to know if I'm facing this guy, if his forward direction is facing this way, right? I have to be facing this way or some area of such, right? You could have some wiggle room, right? So if I want to know that, I can know, I guess we can do if I'm facing him. Facing in the same direction he is. And I'll show you that. So what I need to do is I need to dot my forward with his forward. All right? And if you look at that, I know that this is crazy math magic, but you don't need to know the math behind it. You don't really need to know that unit circle math for it. You just need to know how to use it to solve a problem. If I want to know if my forward direction or any direction I have is in the same direction or in an opposite direction of something else, you can use the dot product. That's really all you got to know. Just when to use this tool. And so if I dotted, it doesn't matter what order you do it in right now. My transform dot forward and bad guys transform dot forward. This is going to give me a value. And if I bring this scary thing back up, say that this is forward, all right? What do, if this returns positive 1, all right? If this returns positive 1 as a float, that means my two vectors are exactly facing the same direction. If it returns negative 1, it means my two vectors are facing the opposite directions. If it returns 0, that means I am 100% perpendicular to that character. Does that, like, without doing any math, can you understand that that this,
The marker at the very end over there.
I got it here, that those two guys if he was facing this way, if I was facing this way, that would equal 1. If I was facing this way or this way, that would equal 0. If I was facing this way, this would equal negative 1. Okay, so that's as much math as you guys really need to know. Now you do need to understand in the middle there that between 1 and 0 is what? An infinite amount of fractions that we can test. But you can start to see if that is the case. So in my code, all I did was I said, take my forward and take the enemy's forward, and we're going to see if we're facing the same way. This would be the start of something like backstabbing. And so this is going to give me a number. I called it half space. It's probably a bad name for that. But if half space is greater than 0.0f, I'm going to say GameObject.getComponents. You don't have to know this. It's not really that important. Mesh renderer. Mesh renderer.material.color equals I don't care, green. Okay, so knowing this code right here, or not knowing this code, not even knowing that, if I said I'm going to dot those two forward vectors, and I'm going to say if it's greater than 0, based on this right here, what is going to happen? I'm not stabbing the back's not happening yet. This is a piece to get you stabbed in the back. Material's going to change, but when? Which means what? If I'm facing in any way direction, like away from him, that number is going to be negative. Does that make sense to you guys? So as soon as I go past 100% perpendicular, I'm going to start going into the negative space. As soon as I start going toward him, facing him, that number is going to go in the positive space. So if I just check to see that it's greater than 0, I should change my color whenever I'm facing in the positive, facing a direction toward him rather than away from him. And let's see if that works. Totally didn't work. That's okay. Hold on.
Did you save?
I might not have. Nah. Still didn't work. You know why it didn't work?
You didn't change your material back after you looked at it.
I never changed it back to red after. So that's cool if it's that way, but else, take all that. And go back to red. I did. Okay, so at this point, what this really means, I'm not checking to see if I'm behind him or in front of him yet, which I would also do with the dot product. I can show you how to do that. This means if I'm facing away from him and I press the button to attack in that, I would not backstab him. If I started facing toward him, now I'm clear to do so, right? And you can do this with visual feedback, and we just created the major steps to doing some type of back attack, right? Critical attack, or whatever. If you wanted to do crit damage from behind, even if it wasn't a backstab, right? These are just the major components from it. So I know when you design these things in your head, you're like, oh, it totally makes sense. If you're behind him, he's vulnerable, stab him in the back, double damage, right? But getting it done requires understanding these pieces. So if you wanted to, that's kind of ridiculous there on that 0. So if I wanted to make this even at a 45, let's make it 0.8. All right? So 0.8, if this is 0, right, you can see the magic that I'm doing here with this. Now, I just said I had this whole place open, right? Anywhere that was more than 45 degree angle. I just tightened that down to about there. So you also see that this becomes useful for cone of vision stuff. If I wanted to do a cone of vision and tighten down a cone of vision to see if something was in that space, this is the exact code I would do. So terms we use and things you think about for game mechanics, use this so much that you better become friends with it. So you get like totally. I guarantee Dishonored uses the dot product. So now it's not perpendicular. It's not even that. I have to be that. I have to be facing him that much to backstab him now or to do something. Otherwise, it's not going to register. It's got to be that. That's the range I have to do my move now. Right? And so I know you guys want to do this stuff. Or I know that you want to understand, like, these are mechanics you're going to think of. And the reason I bring this up and show you these tools is because you guys are starting an assignment that opened on Sunday that is going to be making your own game, right? And so we're going to talk about that. We're going to talk about that. What time is it? I went crazy. Went nuts on this. Lecture's way too long. But I know it's long, and I know there's a lot of concepts that are very large for this space. But in the span of me talking to you and us just talking about vectors, I use vectors to move a character completely, like a 3D character move, barring the camera. I can make the camera a little bit better. I use it to detect how far away I am to an object. So even if I did that too, you could watch this. This is going to blow your mind. So I could do this and what did I say that was? It is vector bad guy dot magnitude is less than or equal to 4, F. Now, I'm even refining this a little more, just using this vector, right? I'm saying, not only do you have to be facing in the same direction, because I'm not green now, right? I have to be facing in the same direction and close enough to do something. Oh, now I'm close enough. Now I'm not close enough. Now I'm close enough, right? So now we've really refined this down to getting a mechanic. And if you wanted to take and slap a little 3D model on this and do a game where you could only run around and backstab people, and that was the only way you could kill them, you're well on your way, right? And only using vector concepts. Like the bulk of this was vector concepts. So yes, there are tons of games that you could find a way to make this, but this tool in your toolbox is so important when you want to get things done. And so I don't think this was taught in the previous version of this class, and you'll understand, and you'll see I'm never grading you on this. I'm never grading you on do you understand or use the vector very well. It's just so important that I need to get the information to you guys so that you can start, you now know of a tool when you think you want to do something or you have a problem set in front of you, you guys have a tool to at least remember the names of ways to solve solutions. And hopefully you say that, like, understanding that vectors are extremely important, hopefully you get that. And you're a little bit probably bored right now of me saying them. But hopefully you're a little bit more excited to go see how to use them and not completely afraid of them. And that's the point. But yeah, this is awesome. Awesome little backstabbing game. Except I can get in front of them and still do it too, which is no good. All I have to do is one backstab, one other check here to see if I was behind him, and then we're golden. And I can do that later in lab if you want to see it. But this, for that game and for that functionality, this is not a lot of code, right? That is not a lot of code, and that is the code that drives a major game mechanic, right? So it's not really scary. You guys should be able to go through this and say, if I wanted those mechanics, go back, and if you didn't completely understand what I was doing, deconstruct each piece of what I was doing here. If I was nice, I would comment it for you, so I would tell you that. But I'm not nice, and I want you guys to struggle looking through it. So what we're going to do is I'm going to let you guys go to lunch, and I'm going to kill this video first.